Hi, everybody. Welcome back to the Chico Math Practice Lab, Learning Through Practicing. And in this video, we're going to talk about we still continue the L'Hopital's rule, and this is practice number 4. So for the past few videos, we talk about the different forms of the limits, so which you can apply the L'Hopital's rule. So in this video, we're going to focus on the limit if my form is 0 times infinities here. Okay, so those are the 6 problems we're going to talk about in this video. As always, it probably is a good idea you pause the videos and then do all these problems by yourself first. And then when you finish, and come back and then we can check the answers. And that's it. And right now is a good time to pause your video, and I'm going to go to the whiteboard, and I will see you later so we can start to work on the problems here, okay? Hi, welcome back, everybody. And so let's start to work on the problems here. As always, before we start, let's do a very brief review what we did so far on this unit. In this unit, we talk about the L'Hopital's rule and which help us to find the limits. So for the previous few videos, several videos, we talk about how to find the L'Hopital's rules if my limit is 0 over zeros, right? And also is infinity over infinity. Those are the two forms of the L'Hopital's rule well applied. And so also the reason why we mentioned the reason why the L'Hopital's rule is very handy is because it's really pretty easy. If you can change it to the 0 over 0 or infinity over infinity, you just take the derivative on the numerator and the denominator, and then you take a limit again. So today we are going to focus on the form. How about if you have 0 times infinities here? So this is the focus for these videos here. And the tricks here is if you have a form is 0 times infinity. So the tricks here is you switch it. So how do you switch it? You can switch to either become the 0 over 0, infinity over infinity, or you manipulate your form and it becomes 0 over 0. Then you can use L'Hopital's rules, right? So that's the key word, the key things here. You need to find a way, change the form, right? Change the form to these two, right? So if you can change that to the infinity over 0 over 0, then we just can apply our rules here. So let's take a look. How do we change it? And we're going to have 6 problems. And after these 6 problems, I think you should be pretty good at that. Okay, let's take a look at problem number A. Part A here. So I'm finding the limit x approach to infinity. Then this is x and the sine pi x here, right? So as always, we said when you use the L'Hopital's rule, you always check. So when x approach to infinity, this is infinities, correct? Then when x approach to infinity, the pi over x, this approach to 0. So the sine 0, what is the sine 0 approach to? The sine 0 approach to 0. So this is the form, is 0 times infinity. So how do we said the way we do those type of the problems is, let's try to switch it, right? So it's 0 times, so that's how do I switch it here. This is limit x approach to infinity. So if I say here, the sine pi x, I put the sine pi x here, and then the x here In here, then you switch back to, so you flip it, right? So this will be 1 over x on the denominator. Then take a look again. After you switch this one, when x approach to infinity, this term approach to zeros, right? And then here, this is x to the infinity. So the 1 over infinity, this term approach to 0. That's how you say, hey, now I change to the, the 0 over 0. Then I can use L'Hopital's rules here. And some people might say, oh, why not? Can I do this way here? Can I put it like this way? Limit x approach to infinity is here. Then you put here is the sign, and then you switch the x here, then you switch the sign to the bottom, then this will be the cosecant pi over x. Yes, of course, you can do this way, and then this ones here will be infinity over infinities, right? Because the cosecant 0 is infinities, right? So that's why, yes, you can do that. And then the reason why we always find the easier way. So some people, they might not remember what is the derivative of a cosecant. So that's why, I change to this way, but you can do either ways here, right? So whatever you feel, but the keys here is try to find the way is easy to take the derivatives here, right? Okay, now that's why I can say, okay, now this is 0 over 0. Then I can use the L'Hopital's rule, and I can find that. So what is the L'Hopital's rule? I take the derivative on the denominator and on the numerators here. So here, the sine pi x, so what is sine? Is the cosine pi x. And every time when you do that, what are the rules we don't want to forget? Chain rules, right? So this is a pi over x. Then you do the chain rule, this will be negative pi over x squared, right? Because you do the derivative of 1 over x is negative pi. Okay, so the 1 over x is the same thing. When you take the derivative, will be what? Negative 1 over x squared. I hope right now everybody should be very familiar with the 1 over x. So like in here, right? This is x to the negative 1. So the derivative of x, so it's negative x negative 1 minus negative 1. So it's negative x squared, right? So I hope that everybody very familiar with that. And now, as you can see, after you do this, okay, so this is a positive, negative cancel. Then 1 over x squared cancel. So what I have here? I have here, this is, I got a pi in the front, right? So I have a limit, x approach to infinity, cosine pi over x. So the pi over x here will approach to 0. So what I know, the cosine approach to 0, the whole thing's what approach to what? Approach to 1s, right? So that's why this limit is pi. And so that's what will be the answer for this problem here. Okay, let's take a look at part B here. So the part B here, I have a limit x approach to 0, sine 5x, and cosecant 3x. Okay, so let's check first. So we always check, like we always talk about in this unit, you maybe are sick and tired of hearing me keep saying check, right? But that's what we need to check. Okay, so this one's here, this approach to 0 because the sine 0. So the same way, so cosecant 0 is what? Is infinities, right? So then we say, okay, it's 0 times infinity. So we need to manipulate it. So put a 1 in the denominator. So here we can say here, this is approach to 0. So here, this is sine 5x. Then the cosecant, well, we know how to deal with the sine way better than cosecant. So we say, okay, let's move the cosecant here. So cosecant 3x will be 1 over sine 3x, right? Now you check again. So what happened here? This is 0, approach to 0. This is 0. So the whole thing's here, approach to 0, and the whole thing's here, approach to 0. So I have a 0 over 0. So now what I can do, I can use the L'Hopital's rules. So we say limit x approach to infinity. So the sine 3x is what? Cosine 3x. Don't forget what I always mention. Hey, chain rules here, right? So you need to times 3 here. So the sine 5x will be cosine 5x. Same way, don't forget the chain rule to 5x is 5. Okay, now you take the, the x approach to 0, this one approach to 0, this one approach to 0. Okay, so now we all know what is the cosine 0? Cosine 0 equal to what? It's 1, right? Cosine 0 equal to what? Equal to 1. So what is the final answer? 5/3, right? Okay, so that's why this limit is equal to 5/3 here. So it's a pretty, it's a pretty straightforward, right? Okay, so now let's take a look at part C here. So as long as you know the tricks here, you need to flip it, right? So it doesn't matter, which one you flip. Of course, you want to find one, after you flip it, it's easy to take the derivatives, right? Okay, so this one's here. Let's take a look. This one, this is the x approach to the negative infinity. So this is the negative infinity. And then here, what is here? Here is zeros, right? So the 0, 1, so this is natural log 1 is approach to what? Approach to zeros, right? So the whole thing is negative infinity, approach to 0. So now I know, okay, so now I know this is possible. I can use the L'Hopital's rule. I just need to manipulate that. So I said, okay, so this is x approach to negative infinity. And for the natural log, I definitely don't want to put the natural log on the denominator. It will be like 1 over. That will be pretty difficult to take the derivatives, right? So I put a natural log in here. So it's 1 minus 1 over x. Then what you do here, you flip this one, right? So you flip this one, become 1 over x. Right, so now you can see this one will become 0, this one will become 0. Then I can use the L'Hopital's rule. Okay, so let's do L'Hopital's rule one more time. So what is the bottom? We say here, everybody should quite familiar with that. So this is negative 1 over x squared. Now the top here, a is a natural log, so it will be 1 over. So it's 1 over 1 minus x. And then don't forget what? Chain rule here, right? So chain rule here. So the chain rule here, 1 is a constant, so it's 0. Now negative 1 over x, so will become positive 1 over x squared. Then you see, okay, good. So this one, I can cancel here, right? Okay, now you put the limit, I'm sorry, I forgot the limit here, x approach to the negative infinities here. So this will be, okay, so you still have 1 negative 1s here, right? Okay, so this one, negative infinity, this will become what? Will become 0, right? So what is the final answer? The limit will approach to? Limit will approach to negative 1s here, correct? Okay, good. Right? Okay, so it's pretty easy. As long as when you flip it, if you find the right one to flip, then you got it. So think about it, right? If you put the natural log 1 minus 1 of x on the denominator, then that's kind of very difficult to do. You need to use the quotient rules first and then take a derivative. So it probably will be easier to put the natural log on the top here. Okay, let's take a look at part D here. Okay, so this one's here, this is limit x approach to infinity. Then this is x to the 3/2, and this is the sine to the 1 over x here. And for this one's here, right? So of course, if you check here, so this is what? This is the infinities, right? And this is 0. Then the whole thing here is zeros here, right? So you can, So you can use the L'Hopital's rule. So this is 0 times infinity. And this one's here, because x3 half, when you take the derivative of that, you know, like then you will have like 1/2 and then sine x, you need to use the chain rule. So in here, I'm kind of going to show you a kind of little tricky ways to do this. So first, okay, so let me show you. I'm going to break the x to the 3/2 to the x to the 1/2, all right, times x. And then here is sine 1/x here. The reason why I want to break this one here, because right now, okay, so I can flip it. So I can flip this one. So this is a sine 1/x, right? And then this is 1/x. I flip this one, right? I can flip this one to here, right? And then I have this x of the 1/2 here. Okay, so now I'm doing here, okay, so I'm going to set here, I was going to find, I said, let's assign the t equal to 1/x here, okay? So the t is equal to 1/x. So I know the limit x approach to infinity, the 1/x is really is equal to what? Is equal to limit t approach to 0 t's, right? Because that's why you can switch that. Okay, so now let's take a look. So that's why I can have here, this will be limit t approach to, okay, so then I can have a limit t approach to zeros, right? Okay, so for this ones here, right, so x to the 1/2, right, t, okay, so let's here. So t equal to 1/x, so x equal to 1/t, so x to the 1/2 is 1/√, of the t's, right? Okay, so I can change this number to the 1/√, of the t's here. Then here, these ones will be sine t over t, correct? Okay, so now you see here, so for the sine t over t here, so I know this one's here, if you let the limit t approach to 0, this one going to be equal to what? Going to be equal to 1, right? Because it's L'Hopital's rule. So this is a t approach to 0, sine t to the t, you can use L'Hopital's rule and say this is 1 cosine t, so it's 1 here, right? So this pink one is 1. Then take a look, 1/t here, right? So the 1/t, when t approach to 0, this number is equal to infinity. So what is the whole thing limit equal to? The whole thing limit is equal to the infinity, right? So that's why this limit is not exist here. Okay, so it's a little bit tricky this way, but I think the, you know, after I explained that, I think you guys should get that, right? Okay, good. Okay, now let's take a look at the remaining two problems. This is the only one I think is a little bit tricky, right? All the other one is pretty straightforward. Okay, so now let's take a look and E part. So this will be limit x approach to 1 from the positive side, from right hand side, natural log x and the tangent pi x over 2 here. Okay, so the first thing is we always check. So x approach to 1, so this one approach to what? Approach to 0. X approach to 1 is a tangent pi. This one is approach to the negative infinity. The reason why this one is negative infinity, because this is my tangents, right? And because I approach to 1 from the right-hand side, that means I'm approaching to pi over 2 from the right-hand side. That's why it's become negative infinity. And but doesn't matter because it is 0 times infinity. So I can still just flip it, right? Okay, so now I will say, okay, let's do this. This limit x approach to 1. So this one I can flip like this way because tangent, I can become the cotangent pi x over 2, right? So that will become 0 over 0. So now let's use the L'Hopital's rule, see what happens here. So this is the limit x approach to 1. So what is the natural log? It's 1 over x. Okay, what is the cotangent? It's a cosecant square pi x over 2. Hey, don't forget what here? Chain rules, right? So it's a pi over 2. Okay, so I'm sorry, this is negative, right? So it's negative pi over 2. Okay, so now, okay, so pi over 2, and so this is a cosecant. So now when x approaches to 1, let's see here, this is 1, and this is a cosecant pi, cosecant x approach to 2, cosecant square pi over 2 is 1 here, right? Okay, so that's good. So I know my answers here will approach to what? Pi over 2. I have a negative sign here. Okay, so that's it, right? So you need to kind of very familiar with your, the trig function. Okay, last problem for this video. So let's take a look. This is the limit x approach to pi over 2 from the left-hand side. So this is a cosecant x, and this is secant 5x is here. Okay, so let's check. Cosecant from the left-hand side. So this one's here will approach to what? Will approach to 0. And cosecant for the left-hand side is here. So what is the secant will approach to? Secant will approach to what? Is infinity, right? Because this is approach to 0. Because I know the cosine is like this, right? Right, so like when they approach to pi over 2 from left-hand side, then the secant going to become to the infinity. So it's 0 times infinity. Okay, so now let's do the same way. Let's flip it. So for this one here, I will, of course, flip the seconds, right? So I will change this is cosine x, and this is cosine 5x here, right? Okay, so now I can use the L'Hopital's rule. I said the limit x approach to pi over 2 from the left-hand side. And what is here, cosine will be the negative sine x. And the cosine is the negative sine 5x. Hey, don't forget what rule? Hey, the chain rules, right? So you have a 5 here. Now you let the x approach to pi over 2. So I know x approach to pi over 2, sine x approach to what? Approach to 1, right? So the sine 5x, x approach to pi over 2. So 5x sine 5 pi over 2 also is approach to what? Approach to 1. So now I know my final answer for this one is 1/5. That's right. So that's why the limit is approach to 1/5. Okay, so this is what is this videos about. So remember, right? So for this video, we are dealing with 0 times infinity. So the tricks here is what? You flip it, right? So you change to, so remember, so you change it to either 0 over 0 or infinity over infinity. Of course, which one you flip, make sure you flip the one, you put the one easier. You want to flip it so you can take the derivative easily for the both numerator and the denominators, right? So if one doesn't work, then try to flip the other one. Okay, so it takes practice, and then you'll get good at it. All right, so that's it for this video. So don't forget, practicing, practicing, practicing. That's the way to make you getting better in the maths here. Okay, so it's nice to talk to you again, and I hope that you find that this one is helpful to help you dealing with the form, the 0 times infinities here. Okay, so our next video, we're going to talk about personal, I think it's the hardest one, is infinity minus infinity. How do we deal with that? Okay, so nice talk to you. Have a nice day.